So the topic for today's lesson is expected value and variance of continuous random variables. So basically, we will focus our attention on a couple of things. One is expected value. Okay, by the end of the lesson, you'll be able to find expected value, which is sometimes called mean, okay, or average for that matter, the variance and the standard deviation, as well as median. Okay, so basically we'll focus our attention on mean, median, standard deviation, and variance. And I trust that you already know the basic idea of each of these terms in your high school. So what is the expected value? Well, the expected value is the mean of a distribution. It's the average of the distribution. Okay, it is the measure of the center of a distribution. Median is a distribution. The median of a distribution is the number in the middle. What it means is, suppose median m, if the median of the distribution is m, then 50% of the data, 50% of the data will be below this m, below the median, and 50% of the data will be above the median. Okay, median means it's a central point by position. You already know that. Variance, the variance of a distribution function, or sometimes called variability, what it does is tells us about how spread out or cluster the data, clustered together the data are, the event are, the possible outcomes are. Okay, how spread out or how cluster, how close the data are. A large variance means the events are more spread out. A small variance means the data are clustered together. For example, if I consider a data, let's say A and B, suppose I have a data here, let's say 1, 20, 100, 150, for example. There are four numbers that I consider. And in B, let's say I consider 1, 5, 7, 10. So if I calculate the variance of this A, then this variance is large. Whereas these numbers are actually, clustered together. So the variability of this, if I calculate the, variability of this data, it will be less. Okay, small variance here, a large variance here. So because the data are spread a lot, that's what the variability tells us. As you can see in this graph, the red graph here is just, clustered together. Therefore, the variance of this distribution will be smaller than the other one. And look at the green graph. Okay, green graph represents a distribution which is really spread out. That means if you calculate the variance of this distribution represented by the green curve, then your variance will be big. All right. And in another word, if the variance is big, the standard deviation also will be big. Okay, too much talking. Let's look at some formula here. Okay. If x is continuous random variable with probability density function f on the given interval a and b, a to b, then expected value, which is mean, is given by e of x, or we use this Greek letter, it's called mu. Okay, this is called mu. This is how we read, equals a to b x f of x dx. So this is the formula. You can prove this formula easily, but the proof is not required. We're not going to prove this here, okay? Maybe I can provide that in my lecture note later, those who are interested. And in the same manner, the variance of x we have the formula here. This is the formula that we'll be using. And standard deviation is square root of the variance, and median. If m is the median, then a to m f of x dx equals half, because the median will divide the distribution into two halves, right? So we have this 4 formula. So using this formula, then we'll solve some of the questions, okay? If you memorize this formula, that's great for the exam point of view. I suggest you memorize the formula, but if you forget, then don't worry, I'm going to provide the formula in the exam. But I suggest that, try to remember this. It will be helpful, not only for this course, but for other course and your career in the future as well. Okay, so example 1 and 2. If you know how to do one example, you can do the other one. So probably we start with example 1. And if you have any question, let me know. And then I will leave example 2 to you guys to do it by yourself, okay? Let's work on example 1. So for both questions, here is the instruction given. A probability density function of a random variable is defined. Find the following. We need to find the expected value, find the variance, find the standard deviation, find median, and then find the probability that the random variable is between the expected value and the median. Okay. So actually in this question, there are 5 other small chunk of the questions, right? So example 1, let me just copy what is given. The function given here is x over 8 minus 1 over 4, and the interval is given 2 and 6. Now, part A, we need to find the expected value. Expected value, which is denoted by mu, equals a to b x f of x dx. So that is the formula. Look at the formula here, a to b x f of x dx. So I'm using this formula from here. So a is 2, b is 6, x, my function is x over 8 minus 1 over 4 equals, this will be 2 to 6, it will be x squared over 8 minus x over 4 dx, which is given by x cubed over 24 minus x squared over 8. If you do the integration, that's what you're going to get, and the limit is 2 to 6. Okay, and so if you substitute the value, so you're going to get, what do you get? 6 cubed over 24 minus 6 squared over 8 minus 2 cubed over 24 minus 2 squared over 8. And if you simplify this, what are you going to get? This is what I got. Okay, my calculator tells me this, but I want to verify this answer with you guys. Okay, I want to make sure that I didn't punch the wrong button in my calculator, and which is approximately 4.67. Any question? Okay, so we got the expected value or mean to be 14 over 3, which is approximately 4.67. So all you need to do is you just copy the formula and you plug in the value and you find the integration. So you are done. So first concept, expected value or mean, is done. Now part B, what we are supposed to do, find the variance. Okay, let us find variance. Variance is, let me just write BR, variance of x is given by, the formula is a to b x squared f of x dx minus mean square or mu square. That is the formula, as you can see here. Okay, the variance, that's the formula. And notice that the integration is only for the first part. The second part is just a constant, and we already know what is mean. Let me substitute the value. A is 2 to 6 x square, f of x is x over 8 minus 1 over 4 dx minus mu is 14 over 3 square. That's it, which means 2 to 6, it will be x cube over 8 minus x square over 4 dx minus 14 over 3 square. How much is that? 14 square will be 196 over 9. 196 over 9. Okay, all we need to do is just evaluate this integral. So that's going to give me x power 4 over 32 minus x cubed over 12. And 2 to 6, the lower limit is 2, upper limit is 6, and minus 196 over 9. So all you need to do is, it's a piece of cake for you guys, so you know how to just substitute the upper limit and subtract lower limit. So you're going to get 6 power 4 over 32 minus 6 power 3 over 12 minus 2 power 4 over 32 minus 2 power 3 over 12 and minus 196 over 9. So use your calculator and let me know what do you get. And my calculator gives me approximately 0. It's 0.8888, something like that. So I write 0.89, but I want to verify this answers with you guys. So I want to make sure that I didn't punch the wrong button in my calculator. So let me see what you got. Okay. All right, so you guys got the same thing. Pretty much everyone got the same answer. That means it must be the correct one. So yeah, we got the variance now. Let me just write nicely. Therefore, variance of x is 0.89. Or you can write 889, so it doesn't matter. Let me write 889. Let us consider at least 3 digits, okay? Now, in this case, we want to find now part C. What we are supposed to do in part C is find the standard deviation. Okay, variance we already find. So now we'll find standard deviation. And the symbol to represent the standard deviation is sigma. Okay, this is a lowercase sigma. This is read as sigma. I trust that you know in your high school that there is one sigma. This is also sigma, and this one is sigma. So this one is the capital, okay, upper case sigma, and this one is lowercase sigma. We use this sigma to represent the sum, and we use this sigma to represent the standard deviation. Okay, standard deviation, the formula is square root of variance of x. So that means square root of variance is 0.889, and this is a piece of cake for you guys. So how much that going to be? It's approximately 0.94. That's what my calculator tells me. Okay. Okay. Part C is done. Now let's try part D. What we are supposed to do in part D is find the median. Okay, part D, we want to find the median. Again, write the formula. We know the formula is a to b, not b, a to m, f of x dx equals half. So this gives me a is 2, m is the median, and the function is x over 8 minus 1 over 4 dx equals 1, sorry, half. So now remember, this is an equation. All we need to do is find the antiderivative, find the integration, and you'll have the equation, solve the equation. So let me just find the integration first, which gives me x squared over 16 minus x over 4 2 to m equals half, right? So this gives me, let me go all the way here. So this gives me m squared over 16 minus m over 4 minus 2 squared over 16 minus 2 over 4 equals half. And if I simplify that, I'm gonna get m squared over 16 minus m over 4 minus 4 over 16, which is 1 over 4, and negative is positive half, equals half. So if you combine them all, this half can be cancelled. So basically you got, what you got is m squared over 16 minus m over 4 minus 1 over 4 equal to 0. Now, in order to make it okay, so now all we need to do is we solve this equation. Okay, this is a quadratic equation. To make life easy, I just want to multiply both sides by 16. If I multiply both sides by 16, I'm gonna get m squared minus 4m minus 4 equals 0. Okay, it cannot be factorized easily, so all we need to do is we need to use the formula. You know that the quadratic formula, right? Quadratic formula, recall that. If you have ax squared plus bx plus c equal to 0, then x can be written as minus b plus minus square root b squared minus 4ac over 2a. So we're going to use that formula to find the to find the value of m. So that means m will be negative 4 plus minus square root b square means negative 4 square b square minus 4, a is 1 and c is negative 4, 4ac divided by 2a1. So which gives me 4 plus minus, this is going to be 16 plus 16 is 32, and over 2. So this can be written as 4 plus minus, 32, square root 32 can be written as 16 times 2, which can be written as 4 root 2, okay? So I can write 4 root 2 divided by 2. So that's going to give me 2 plus minus 2 root 2. Okay, now remember the domain here is 2 and 6. Can you check whether 2 plus 2 root 2 lies within that domain and 2 minus 2 root 2 lies within that domain? So can you use your calculator and check which one is either, whether both of these value lies between 2 and 6 or not? Okay, because we are given this as a domain, so any value beyond this interval cannot be median. So we'll choose the one that has that lies within that interval. So my calculator tells me that this one is not in domain. Okay, it does not lie within 2 and 6. So our median is therefore median m equals 2 plus square 2 root square 2 square root 2, because 2 minus 2 root 2 is not in the domain 2 and 6. Okay, this is not in the interval 2 and 6. So just this. Any questions so far? So we have done part A, B, C, D, and there is part E. What is part E? Let me check that. Part E is find the probability that the random variable is between the expected value and the median. Between the expected value and the median, okay? Remember, in our previous class, we defined probability as definite integral. So we're going to use the same concept here. So what we want to find is, we want to find probability between mean, between mean and median. Okay, that's the question. Find the probability that the variable lies between mean and median. So that means we can write this as probability of mean is 14 over 3 x, and then the median is 2 plus 2 root 2. And we define the probability to be integration, definite integral, which is 14 over 3. And this one is 2 plus 2 root 2 is your upper limit. You need to check which one is bigger, okay? It says that between mean and median. So if the median is smaller, you know, my common sense tells me that 14 over 3 is less than 2 plus 2 root 2. Therefore, I wrote that 14 over 3 there. Okay, if median if median were the smaller quantity, then I would switch this to. Anyway, so we have this integration and f of x dx. So we know that the probability can be defined, probability is given by the definite integral. So we write the definite integral. So basically all we need to do is we need to evaluate this integral and we'll get the value. 2 plus 2 root 2, and the function is x over 8 minus 1 over 4 dx, right? So that's going to give me x squared over 16 minus x over 4, and 14 over 3 is your lower limit, 2 plus 2 root 2 is your upper limit, and then yeah, that's it. You just plug in the value now. So you're going to get 2 plus 2 root 2 squared over 16 minus 2 plus 2 root 2 over 4, and then minus 14 over 3 square, 14 over 3 square over 16 minus 14 over 3 over 4. Okay, guys, it's just all numbers, and you just plug in those values in your calculator and let me know what you get approximately. I'll wait for you. My calculator tells me that it is 1 over 18, but I want to verify with your answer, guys, okay? So it is 1 over 18, and this will be, if I change that into decimal, I'll get 0.0556, which is approximately 5.5%. Any questions so far? Okay, so you guys got the same thing. So great. So because we all of us get the same answer means it must be correct one, because it's very difficult to get the same wrong answer. Okay, now let's move forward. Let's try example 3. I trust that you can do this by yourself, but anyway, let's try just for fun, okay? So example 3 is also very similar to example 1 that we have done earlier, but let me just, I know that some of you have already done and you already given me the answer in the chat box. I'm gonna just copy and paste those answers here, okay? Because so many of you got the same answer, that means the answer must be correct. And here in part A, okay, let me just copy the function given f of x equals x cube over 4, and the interval is given 0 and 2. So in part A, we need to find expected value, which is denoted by mu, is given by the formula a to b x f of x dx, which is 0 to 2 x and then x cube over 4 dx. And I trust that everybody know how to evaluate this integral, and you're going to get 1.6. Okay. Part B, find the variance. Okay, variance is given by the formula a to b x square f of x dx, which is given by 0 to 2 x square, and the f of x is x cube over 4 dx. And if you evaluate this integral, so you're going to get 8 over 75, which is approximately nearest hundredth. Look at the question. Nearest hundredth means we need 2 digit after decimal, only 2 digit. Okay, pay attention to the instruction. So when you convert this into decimal, and if you need just 2 digit after decimal, okay, that means it's going to be 0.11 when you round it up. And part C, standard deviation. Okay, standard deviation given by this is square root of variance of x, which is square root of 8 over 75. Okay, to be more precise. And then when you do that, so you're going to get 0.3266, again nearest to 100. Round it nearest to 100. When you round it up nearest to 100, you're going to get 0.33. Okay, part D. Find the probability that the random variable has a value greater than the mean. So basically we need to find probability greater than the mean. So the mean is, it should be greater than mean, and less than the upper limit is 2. So it should be somewhere there, which means probability of mean is 1.6 x2, and we know that the probability is given by the definite integral, which is 1.6 to 2 and f of x dx. So that's going to give me 1.6 to 2, and the function is x cubed over 4 dx. And if you find the antiderivative, so you will get I believe you'll get approximately 0.59. Okay, All right. And that's what you got, right? Let me check what you got there. Yes. Okay. So to be more precise, 0.5904. But in this quest, in part D, do we need to round it up? Do we need to round to nearest 100,000, anything? Part D, okay, nothing. So in that case, let us write at least 4-digit after decimal, okay? If it doesn't say anything, then we can, 4-digit is enough after decimal. Okay, and then part E, find the probability that the value of the random variable is within 1 standard deviation of the mean. Okay, within 1 standard deviation of the mean. Use the value of the standard deviation to the accuracy of your calculator. Okay, what we need to find is, we need to find a probability that the random variable lies within 1 standard deviation from the mean. Okay, within 1 standard deviation from the mean. What does that mean? Suppose there is a mu here mean, and so you go 1 standard deviation this side, 1 standard deviation this side. So if you want to go 1 standard deviation this side, so that's going to be mu minus standard deviation. And if you go 1 standard deviation this side, this point will be mu plus standard deviation, and this one will be mu minus standard deviation, right? It's just a common sense. And so this side will be mu plus standard deviation. Okay, that's all we need to calculate. So within 1 standard deviation, so the probability within 1 standard deviation from mean is given by this. And this means mu is 1.6 minus a standard deviation is, we round it up, but the question tells us that just write the exact value here, okay, from your calculator. So 0.3266 x mu is 1.6 plus 0.3266, okay. And if you calculate them, you're gonna get 1.6 minus 0.3266 will be 1.2734. If my calculation is wrong, please let me know, okay? My calculator tells me this is the value, but I might have punched the wrong button. I want to verify with you guys, okay? And the upper limit will be 1.9266. Okay, that's it. All you need to do is find the integration, because we have defined the probability as definite integral. So it will be 1.2734 and 1.9266. And your function is x power, what is the function again? X cubed over 4 dx. And I trust that everybody know how to evaluate this integral. And then somebody already got the answer in the chat box, and I'm gonna just copy and paste that value. So it's gonna be 0.6967, and which is, you can write 69.67%. Okay. Some of you asked this step, I believe. Is this the step that you want me to explain again? Remember, we need to find probability. See the question here. Find the probability that the value of the random variable is within, value of the random variable x is within 1 standard deviation of the mean or from the mean. So let me ask you one thing. In the number line, okay, let's say this one is your mu, which is 1.6. Now, within 1 standard deviation, when we say within 1 standard deviation, so that means it can go up to this is your standard deviation and this part is your standard deviation. So you can go one standard deviation on left and right both. If you go to one standard deviation here, and let's say standard deviation equals, how much is that? 0 point something. So this point will be 1.6 or mu minus standard deviation. Okay, if this one is 2, for example, in a number line, let us look at, you have a number line here, and suppose 1.6 is there, and then there is 0.3, for example, then what is this point? If you come 0.3 on this side, so what you need to do is you need to subtract, right? So this point will be, this distance is 0.3, so it's going to be 1.3, and this distance is 0.3, and this point will be 1.9, right? It is within one standard deviation, within that. So left and right both. I did the same thing here. One standard deviation, and that's what it means. And then when you solve, that's what you're going to get. Any questions so far? Okay. So one more question. Let's try this just for fun, okay? Find the expected value, the variance, and the standard deviation when they exist for the following probability density function. Now the question is there any situation where some of these values do not exist? Can that happen? Can some distribution may have no expected value? Can some distribution may have no variance or no standard deviation, or maybe undefined standard deviation? Is that possible? Well, let's look at that, okay? Expected value mu is given by the formula, you know that, a to b x f of x dx. Now remember, there are two pieces here, okay? So the interval is basically, what is the interval here? The lowest value is 0, and then the upper limit is actually infinitive. Does that make sense? Because x is greater than 2 means it can go up to infinity. So basically, because this is a piecewise function, we need to split that into two pieces. One piece will be 0 to 2 x cube over 12 dx, and there is x already. Let me write that x here. X times x cube over 12 dx plus, and for another piece it will be 2 to infinity x times 16 over 3x cube dx. All you need to do is you evaluate this two integral, okay? I trust that everybody know how to evaluate it, and it's going to be 0 to 2, so you'll get 1 over 12 x power 4 dx plus this guy will be 16 over 3, 2 to infinity. It will be x power negative 2 dx. Okay, I leave it to you guys. I trust that everybody will be able to do it yourself, and the final answer you should be getting is 16 over 5. Should be your final answer, okay? Adding both of these. Now, this is not a big deal. Expected value, I think everybody will be able to do it. Now, let's look at variance. Variance is given by 0 to infinity Let me just copy the formula. So that's going to give me there are two pieces here. So we have to split that into two pieces as before. So 0 to 2, x square x cube over 12 dx plus 2 to infinity x times 16 over 3x cube x square, not x square 16 over 3x cube dx minus mu square means 16 over 5 square. Okay, I trust that you'll be able to solve this integral. So let me write this integral. So 0 to 2, it's 1 over 12. You're going to get x power 5 dx plus this going to be, let's write the limit 16 over 3 limit b tends to infinity. You know how to evaluate the improper integral, right? We have already learned how to evaluate the improper integral. Whenever there is an infinity, we consider that limit b to be infinity, and here we'll write b. So you're going to get 1 over x dx minus 16 over 5 square. Okay, so this is going to be 1 over 12. So it will be x power 6 over 6, 0 to 2, plus 16 over 3, limit b tends to infinity. So it's going to be ln x, right? Ln x, and then this will be 2 to b minus 16 over 5 square. So this guy will be 1 over 72. So you'll have 2 power 6 minus 0 power 6 plus 16 over 3. This will be limit b tends to infinity ln b minus ln 2 minus 16 over 5 square. And okay, so this guy is 2 power 6 is, how much is that? 2 times 2, 4, 8, 16, 32, 64. 64 over 72 plus 16 over 3. So that's going to give me, oh, you see this part is undefined. Can you see that? This will be ln b. Ln infinity is undefined. So you don't have to do anything here. Since ln limit b tends to infinity ln b is undefined, the limit, what is the word that we used earlier? I think we look at whether the integral converges or diverges, right? When we are working with improper integral, since b tends to infinity ln b is undefined, you can say equals infinity. You can also write this, the integral, the whole integral diverges. So this means, so the distribution has, or so it has neither variance nor standard deviation exist. Okay, because the integral is divergent, or in another word, it's undefined. So variance and standard deviation do not exist. Any question, guys? So from this example, we learned that in some situation, the distribution may not have, I mean, it is possible not to have, uh, standard deviation or variance, or sometimes even the mean. That is possible, okay? Now, the last question for this section is example 5. Let's look at this. I trust that you can do it by yourself. I'm going to give you, little hint, and then you may want to try it on your own, okay? This is a nice application questions of probability. An insurance policy reimburses dental expenses X up to a maximum benefit of $250. The probability density function for X is given by, I don't know why I wrote this double f of X. Anyway, f of X given by the piecewise function, as you can see here. And the first piece is for X greater than or equal to 0. The second piece is otherwise, where C is a constant. Find the value of C and calculate the median benefit for this policy. Choose one of the following. Okay, let me just cancel that. There is no, anyway, I'll give you some possible answers. Okay, let us look at this from multiple answer choice perspectives. Suppose I'm going to give you part A is, okay, let me give you the answer choice. Let's say this is 161, part B is 165, part C 173. Okay, so these are the 5 answer choice given, and you may want to choose the correct one. Okay, now little hint. The first thing is we need to find the value of C. First, we need to find value of C. Now, how can we do that? Do you remember from the previous lesson that when we need to find the value of K for the function to be PDF, then what we did is we used the condition of the probability density function, right? Since f of x is a probability density function, what it means is a to b f of x dx must be equal to 1. We know that. There are two conditions. One is f of x is non-negative, and from this one we may not get the exact value of c, but since we are interested to find the exact value of c, we will consider the equation, not the inequality. Okay, solving this equation, you will be getting the value of c, just like before. So this is nothing new really. Okay, a is lowest possible value is 0, and the highest possible value is infinitive. And f of x is, okay, there are two pieces. One is ce raised to power negative 0.004x dx, plus another is, for another one is 0. Oh, I don't have to write that 0, simply this one equals 1. Okay, it turns out to be pretty straightforward questions. When I look at the question, then you might have thought that, oh, how do I do this questions? But you see, this is not a big deal. All you need to do is evaluate this integral. So limit b tends to infinity, 0 to b c e raised to power negative 0.04x dx equals 1. So you're going to get c e Notice that this term will be 0 if I substitute the value, okay? So we know that since, or I can simply write this, C over negative 0.004, and this guy will be 0 minus 1 equals 1. So you're going to get, what is the value of C then? Simply 0.004, is that right? Okay, this is the value of C. We are done. Therefore, the function is, the given function is f of x equals 0.004 e raised to power negative 0.004x, because you see the function is c here, and once you substitute the value of c, that's what you're going to get. Okay, f of x is the original function is c e raised to power negative 0.004x. Once you substitute the value of c, then this is the function. Okay, first part is done. We are supposed to find the value of c. We have done that part. Now what we are supposed to do now, find the value of c and calculate the median benefit. Okay, we need to find the median benefit. We need to find median. To find median, again we have the formula, median, and represented by m. So the formula is a to m f of x dx equals half. So a is 0 to m, and my function is 0.004 e raised to power negative 0.004x dx equals half. All you need to do is evaluate the limit. Calculate the integral. Okay, evaluate the integral, and so that you'll get the equation there, and solve the equation and let me know what is your final answer. Okay, I leave it to you now. Okay, so we already know the median, the formula, and all we need to do is evaluate the integral, and you guys already know how to evaluate the integral. E raised to power negative 0.004x divided by negative 0.004, and you will have lower limit is 0 to upper limit m equals half. Oh, this one, the nice thing is we can cancel that out. So what you got here is negative e raised to power negative 0.004 m minus e power 0 equals half. So that's going to give me negative e raised to power negative 0.004 m, and then plus 1 equals half, right? And so negative e power negative 0.004 m equals negative half. If you subtract 1 both sides, that's what you're going to get. Negative, negative cancel out. We need to find the value of m. So recall from your high school or pre-calculus how to evaluate this kind of exponential function. I trust that everybody know. What we do is we take the logarithms, both sides, taking logarithm ln e raised to power negative 0.004 m equals ln half. And so ln NE, you simply get negative 0.004 m equals ln half. And so your m is going to be ln half over negative 0.004, and which is approximately 173, right? This is approximately 173. Okay, that means the answer is part C. This is the answer. Okay, all right, guys, we are done with this section, and I trust that if you know how to do the problems that we solve in this class today, you'll be able to handle pretty much every questions in the homework and hopefully in the exam as well. In our next section, next lesson, we will look into three different kind of probability density function. One is uniform distribution, exponential distribution, and normal distribution. These are the three types of distribution that we'll be looking into in our next lesson. Okay,